I'm 𝗖liche from the Wuhan University. So my talk today is monitoring the hourly dynamic of nighttime light using an UAV. I come from the Wuhan University, and my institute is the name is 𝗖cie Laboratory for Information Engineering in Surveying, Mapping, and Remote Sensing. So, sorry. So my talk will include five sections. First is about the motivation of this study. As we know, the satellite imagery has been used for mapping city light at night in different research fields. So this is a DMSP images at global scale, and other images including the views, also some image like International Space Station or the 𝗨𝘀 #1 satellite from my university have also played a very important role for the city light mapping. However, although I have been in this research field for many years, I find that the coarse resolution and the relatively fixed overpass time of satellites have hindered fully understanding of the nighttime light. For example, some questions may be not answered by the satellite imagery. The first is how land use contribute to the nighttime light intensity, because you know that the land use is highly spatially heterogeneous, but the spatial resolution of the satellite image, such as DMSP, is more than 1 kilometer. The second is how land use contribute to the nighttime light colors. Yeah, this is also cannot be answered by DMSP or the views images. Also, how the light of the different land uses change during the night, because you know that for most of satellite only visit one place for one night or even many nights. So it's very difficult to know how the light change during a night. So under this background, I find the UAV may be an potential tool, because the UAV have been widely used in daytime remote sensing and have potential for nighttime remote sensing because of the following reasons. The first is flight time is flexible, because you can use the UAV to record the city lights of a place for any time, like in both daytime and any time in the night. The second is atmosphere effect is relatively minor, as the flight height is very low, because it's normally lower than the 500 meters. The third is the spatial resolution is very high. For 𝗨𝘀 satellite UAV is if the flying height is like 500 meters or 300 meters, the resolution is about 1 centimeter, so it's very high. The final reason is the flight cost is very low, because you don't have to pay any data cost, for the flight. The only thing you have to spend is labor. So these advantages may help to solve the above mentioned problems in the last slide. So in this research, to test the potential of UAV to surveying and mapping city light at night, we employed 𝗨𝘀 Phantom 4 RTK UAV. The study area is located in the Wuhan University campus, and the detailed information for this location is Faculty of Information Science. The area is about 0.38 kilometer squares, and the urban functions are also mapped through the fieldwork in the right. Yeah. So this is daytime imagery recorded by the UAV. This is our flighting route. And we use 10 flights to map the city lights in the research areas. during about 8 p.m. the 15 April 2019 to the next day, and the time is 5 a.m. So for each two flights, the interval time is about 1 hour. So we can say that we use a UAV to map the hourly nighttime light dynamics. So this is a video that is showing how the UAV works in the research areas. Okay. So in addition to the UAV we also employed the 3 SQM, which the full name is sky quality meters. Although these tools are always used to map the sky brightness, it can also play an important role to record the brightness of the ground or any other target. So the 3 SQM are located. One is for the upwards, and upward in the to record the sky brightness, and also second one is located to measure the temporal dynamic of. I'm sorry, to the dynamic of the ground brightness. And the one is located to measure the spatial distribution of the light from the ground. Photogrammetry software to generate image mosaics for the 10 flights. So we can say that the first hourly temporal resolution image of the city lights were generated by our UAV data. Yeah, so this is the flash. So firstly, the SQM1, which is a moving downward SQM measurement, has shown a very good correlation with that of the UAV images. We can see that for the red band, green band, and blue band, all the correlation between the UAV measurement and the SQM measurement is more than 0.6 in the R-squares for the linear regressions. And also the regression R-square is also high, more than 0.7 for the brightness of the UAV. But it's very interesting to find that the green band has a higher correlation than other bands with the UAV image. So we find that SQM have a spectral response in the peak for the green band. So that can explain why the UAV green band is more consistent with to the SQM measurement. So both the measurement from the SQM2 and SQM3 showing that a strong correlation with the UAV images in time series. The result indicates that, for example, the SQM measurement, which record the ground brightness, has a R-square R-square in the linear regression of more than 0.98. Yeah. So also the measurement that records sky brightness has a very high correlation with that of UAV. The correlation is also more than 0.96. Yeah. So this result shows that the UAV is capable to measurement the light at night in both spatial and temporal dimensions. So we also use land use map to overlay with time series UAV images. We find that the night light presented a continuous decline from the 8 p.m. to 4 a.m., losing more than 60% of the total brightness during the period. And also the largest decline, the night light took place during the 9 to 10 p.m. Also, the pattern of the light dynamic varied among different urban function classes. For example, the outdoor sport field, indoor sport field, commercial and residential lost more than 90% of the lights during the 8 p.m. to the 5 a.m. This is a figure to show the percentage of brightness loss between the 8 p.m. to the 4 a.m. We also used some statistic to map the light off time. This map is the map to show the pixels that with the time of the pixels that with the largest nighttime lamp decline. So different colors to denote different light off time. So for example, the red area is a tennis court, which was turn off light in between the 8 p.m. to 9 p.m. So this is the case. And the blue area is also a case that's showing the nighttime change between the 4 and 5 a.m., which is a club or which is a bar. For the color analysis, we also find that the blue band had a more relative change during the 8 p.m. to the 5 a.m. The major road is much less blue during the period, and only commercial, residential, major road, and open ground are less blue. This is a map to show this is a figure to show the relative spectral ratio of the blue band. Some of the urban functions are become less blue. Yeah. So why? Also, if you can take some details to look at the image with a side view, we can see that this image in the major road that where the LED lights is turned on in the 8 p.m. So the major road is include some blue lights from the LED lights. But in the 4 a.m., the LED lights in the nearing commercial buildings was turned off. So that's why we can say the blue light is distinguishing during that time. So we can say the major road is becoming much less blue. Also, this is a case to show how the side view of the UAV is capable to provide more information of the city lights. This is a nightclub. Also, from this image, because this is the vertical observations, the spatial details information are not is not shown in this image. But we can, if we can observe it with a side view, we can see that the door or gate of the window of the buildings is clearly by the side view. But firstly, UAV is a powerful tool to record the nighttime light. The UAV acquired images were consistent with ground measurement. The second point is the analysis on the UAV images indicate that the city light is highly dynamic and complex in both spatial and temporal dimensions. Because this is a case study, so we can say that the patterns we find in these studies may vary from one location to another. So the only conclusion we can say for the patterns is highly dynamic in both spatial and temporal dimensions. Also, the side views will provide more information on the observation of the light. So our group is still working on UAV observations with side views. I think we will publish a paper on that. So this work is summarized in one paper published in the Remote Sensing of Environment in the last year. Okay, thank you very much. So I'm happy to answer any questions from the audience. Thank you.